Our next presentation today is by Dr. Virginia Andrews-Goff, Innovations in Whale Science. I do note that she actually changed her title, which used to be called Innovative Whale Science, and I was hoping to hear something about the innovative whales. So Virginia has worked in science branch since 2012. She really focuses her research on whale movement, satellite tag design, health impacts, and developing a drone sampling platform for large whales, which she'll talk about today. She provides cetacean management and conservation advice to government and professional regulatory bodies, and is a member of Australia's delegation to the Scientific Committee at the International Whaling Commission. Welcome, Virginia.
Okay, hello. Yes, I'm going to be speaking to you today about innovation in Antarctic whale science, though I have no doubt that our whales are innovative also. I'll be speaking on behalf of the rest of the whales team, Mike Double, Eleanor Bell and Brian Miller. So why does the department do whale science? I'd like to bring your attention to the green box down the bottom of this infographic, the needs and outcomes. It's the role and responsibility of the department to manage threatened cetaceans in relation to anthropogenic impacts, fisheries and offshore development. This need relies on high quality data and high quality translation of research to policymakers. AAD Science fulfills this dual need. We undertake the research to understand all those elements presented in that orange box there, understanding aspects like predator-prey interactions, anthropogenic impacts, abundance and trends, and threats to whales. This science then underpins our advice to government and professional regulatory bodies, as well as our supporting our engagement in the International Whaling Commission and CAMLR. However, this data is really very hard to get. Whales are notoriously tricky, especially when they're located deep in the Southern Ocean, close to Antarctica. We usually need to charter a large vessel to get ourselves into the Southern Ocean and close to these whales. And when we get there, we then need to find the whale, an animal that spends the majority of its time below the surface of the ocean. Once we've found that whale, we need to launch a small boat to get close to the whale in order to generate data streams critical to conservation and management. But that's only if weather windows and swell conditions allow. Perhaps unsurprisingly, AAD Science is the only research group in Australia undertaking work on whales in Antarctica. And we've been able to do this due to long-term investment and persistence to develop suitable research methods. This degree of persistence is such a good fit for government science, but not as easy to implement within academic settings. So together, in partnership with our Technology and Innovation branch at the Antarctic Division, we've developed a range of methods and technologies that are world-leading. The first here, in this photo of my colleague Brian Miller, is a sonobuoy. We throw this sonobuoy over the side of the vessel and we use it to listen out for whales. When we hear a whale, we can track and locate that whale in real time, helping us to actually find whales deep in the Southern Ocean. We've also developed moored acoustic recorders, which we deploy deep in the Southern Ocean, and these record whale sounds and help us look at the broad-scale distribution of whales across months and years. And we've also developed satellite tagging technology, which helps us look at those finer scale movements of whales, both on their feeding grounds and along their migratory corridors. These are all technologies that have been pioneered at the Antarctic Division. These methods and technologies have allowed us to generate data sets that are world first, and you're watching one at the moment. This is an animation of our satellite tag-derived humpback whale movements, moving between their coastal breeding grounds along the east and the west coast of Australia down to their Antarctic feeding grounds. This was the first data set of its kind, and we've since generated satellite tag-derived movement data sets for Antarctic blue whales, for pygmy blue whales, for southern right whales, and for minke whales. It's these technologies and methods that have allowed us to undertake 5 highly successful research voyages over the last 10 years. Each of these voyages becoming more multidisciplinary in nature and laying the groundwork for the future direction of the predator-prey research within our program, looking at the sustainable management of krill and the krill-based ecosystem. we have now shifted our focus to the exciting opportunities associated with the arrival of the Noina. We are working now to develop a new range of cost-effective and efficient technology and methods to deliver whale science. And these include things like an infrared camera system to automate the detection of whales from the Noina, using long-range fixed-wing drones to undertake our wildlife surveys, and developing a drone-based platform to sample large whales. I'm going to leave you today with a quote attributed to Steve Jobs. "Innovation distinguishes between a leader and a follower." The Australian government has always been a leader in the development and application of non-lethal science on whales. By getting these new technologies off the ground, we can radically improve the way we work, generating better data via safer methods with greater ethical consideration, and we continue our strong presence and advocacy of conservation and management of whales. Thank you.